Hello there, I'm Ben, and along with Alex, Peter, and Stephen, I will guide you on this wonderful journey through the depths of a substance which is known as crude oil. So crude oil is made from decomposed fish, plants and marine animals, and dinosaurs, over millions of years. It can be found in crevices and rocks very deep in the earth, and the easiest crevices to reach are those at the bottom of the ocean. The reason they are so low down is because the animals and plants that form them lived so long ago, and the gradual process of fossilization takes millions of years. This means that over time, more and more rocks have formed on top, pushing the crude oil down deeper and deeper. So crude oil is a non-renewable resource, so which means it will run out eventually, but it is still a very major part of producing energy for our everyday lives due to it being very efficient, relatively cheap, and alternative fuels not being developed enough to replace it, such as hydrogen fuel cells. Despite providing energy, it comes with several downsides. The most prominent being that burning crude oil releases CO2, which can cause global warming. In addition to this, you need to drill very, very deep down to reach the crude oil, and if any oil spills happen, it can have a devastating effect on the environment, such as the BP spill in the Gulf of Mexico.
Crude oil is a mixture of compounds called hydrocarbons, which contain only hydrogen and carbon atoms. The carbon atoms come from carbon-based fossilized organisms. Crude oil is made up of many different length molecules of these hydrocarbons called alkanes. Alkanes have only single bonds between the atoms, and we call these molecules saturated. They come in the formula CnH2n plus 2. For example, butane has 4 carbon atoms, so we can work out the number of hydrogen atoms it has by using the formula 2n plus 2, which equals 10. These alkanes all have different boiling points and properties, and as a result we have different uses for each of them. We fractionally distill these alkanes to separate them, where we can then use them for whatever purpose according to their properties. To fractionally distill crude oil, it first has to be transported to a fractionating column. We usually do this via pipelines from offshore oil rigs and then move it to containers and trucks where it is shipped off accordingly.
Different lengths of alkanes have different uses. For example, shorter ones can be used as fuel, for example petrol or diesel, and the longer ones can be used to make roads. These different uses come from different properties, and as you go from shorter to longer alkanes, the flammability decreases, boiling point increases, viscosity or thickness increases, volatility or how easily it turns to a gas decreases, and the flame becomes less clean. The crude oil is superheated until it is all a gas and sent into the fractional distillation column. Different molecules evaporate and condense at different temperatures, and those with the higher boiling point will condense first and be separated into a separate pipe. Meanwhile, the other molecules with lower boiling points will continue to rise up the column and condense into their relative pipes. Although this method is not entirely accurate at separating out individual lengths, ones with similar lengths have similar uses, for example ethane and methane, so can be grouped together.
In crude oil, there is a higher concentration of large molecules used for roads than there are small molecules. However, there is a larger demand for smaller molecules than large. To get to know this problem, we do something called cracking. The definition of cracking is breaking a large alkane into a smaller alkane and an alkene. Alkenes are more reactive than alkanes because the double bond can be broken and the molecule is unsaturated. We crack by passing the vapor of an alkane over a hot catalyst, which speeds up the reaction. This is a thermal decomposition reaction, and an example would be an alkane with the formula C8H18 forming the alkene C4H8 and the alkane C8H10.
The difference between alkanes and alkenes is that alkenes have a double bond in them. This means they are unsaturated. You can test for alkenes by putting them in bromine water and watch it as the bromine water turns from orange to colourless. The double bond can break in lots of alkenes, which are also called monomers, and they join together to form a very, very long chain polymer. And these are literally plastics. So an important phrase to remember: the double bonds break in lots of monomers, then they join together to form a long chain polymers. And when we're talking long chain polymers, these could be in excess of 50,000 molecules long.
Once we have cracked the longer length alkane into an alkane and alkene, we can use the alkane as a gas fuel. However, we still have a spare alkene remaining. Rather than waste this alkene, we use it with many other spare alkenes to make plastics. Plastic is a very useful material that we can use for many things.
There are two different types of plastics, thermosoftening and thermosetting. These are made using lots of the chains of the polymers together. Thermosoftening plastics have a lower melting point and we'll use them in things such as plastic bags. They have weak forces between the chains, and this is what gives them a low melting point. They are very useful as plastic bags because they can stretch up and down, but their positioning means the chains cannot slide over each other and so will not stretch the other way. When the plastic bag is about to break, it will stretch due to the way the layers are positioned, letting the carrier know the bag is about to break. Thermosetting plastics, however, burn or char when they are heated and don't melt. We use thermosetting plastics in things such as kettles and hot water bottles because they have a high melting point and cross-links between the chains make them rigid.
Plastic is a very useful material that we can use for many things. However, when a plastic comes to the end of its useful life, as it were, we do have trouble disposing of it. Plastics are non-biodegradable. They do degrade, but they take 500 million years. Non-biodegradable means it is not broken down naturally by microorganisms. It means we have to think of other ways to get rid of it. One of the things we can do is reuse it. This means we simply clean it out and then continue to use it for its current function. We can also recycle it. Recycling plastics mean we melt them down to a liquid, shape them, and then use them for a different purpose, like milk cartons or plastic bags. Some types of plastics are called smart plastics because the polymers they are made of react differently to normal polymers like hydrogel, which fuses together in water and is used to make gum shields to melt into your mouth shape.